This one's exactly the same thing. It's just written different. It's f over g of x, which we've seen these. We've seen these functions written like this, right? So all this is telling us then is really to take f of x and divide it by g of x like this. Okay, well that's nice, but what is f of x and what is g of x? Well, it tells me up here f of x is x squared plus 8 plus 21. So I just replace it with its expression. And then g of x is x plus 3. So that's our denominator. And you can see it, I mean, is this a lot of work to get from this to this? No. Is it even a lot of writing? Well, I use the technology. But a lot of this stuff is skipped. Most students would just say, okay, it's f over g of x. They just write it like this. They don't really need all this stuff. But again, if it helps you to see this, then so be it. But now that we have that, we're ready to use some long division, right? So I'm going to take my x squared plus 8 plus 21, and that would go inside of the long division symbol. And then our denominator is always on the outside. Okay, now just so everyone understands, this does read x squared plus 8x plus 21, all divided by x plus 3. It's just written with long division. So here, again, just focusing on my x and then the x squared. Well, that x is missing an x. There's not a coefficient here to really match, so we're just going to keep that as a phantom 1. X times x would be x squared, which we've used. And then we'd have the 3 times x, or x times 3, which would be 3x's. Again, those have been used. So again, the purpose there was to zero out our x squared. And then I've got 8x's minus 3x's, which is 5x's. And then my positive 21 just drops. Now, I've got 5x's and then an x, so I don't really need another x, but I need 5 of them, right? So I'm going to have to take that x and multiply it by 5. The 5 there in red is positive, so I know it's going to be positive 5 there. 5 times x is 5x's that have been used, so subtract those out. 5 times 3 is 15, but again, those have been used, so that's subtraction as well. We zero out our x's, and we're left with a remainder of 21 minus 15, which is positive 6 here. Now, again, how do we know there's a remainder? Because there's no other x's to work with. This x, just like the last one where it was x squared here, but we had x's in the end, there's not enough x's to work with, okay, without dividing by x, which we don't want. I mean, we can show it in the quotient, which is fine with the remainder, like this, right? So x plus 5 is our quotient, but our remainder is 6. Or you could write it as a full expression with x plus 5, and then your remainder is just added to it. Well, the remainder was 6, and it would be 6 over whatever the denominator was in the beginning. So this is how we would want to see the division here. Otherwise, you're going to make this, well, it'd be really ugly at least. But yeah, either one of these, again, it just depends on how it words it in the assignment. Does it want the quotient and the remainder? Does it want the quotient with the remainder? It should specify, though. We've seen remainders. I expect that there will be, but I can't guarantee that all of them will have remainders. Like if this was a minus 21 right there just is no remainder, and then the quotient is just your final answer. I don't know that happens very often or ever, but it could.